Hello, Algebra 2 students. It's Mr. Lamb here, getting ready to go through the Unit 7 Transformations of Functions review. One of the things that I want you to remember, as we talked about in class, anytime I am making changes vertically or along the y-axis, I am basically going to do exactly what the function is telling me to do. If I want it to move up, I'm going to add. If I want it to move down, I'm going to subtract. If I want to stretch it, I'm going to multiply by a number bigger than 1. If I'm going to compress it, I'm going to divide by a number or multiply by a fraction that's less than 1. When we're dealing along the horizontal axis, however, we talked about being in the parentheses. We always have to remember that with the x coordinate, we always have to think opposite. So if I want to move right, I'm going to subtract. If I want to move left, I'm going to add. If I want to stretch, I'm actually going to multiply by a fraction less than 1 or divide by a number. And if I want to compress, I want to multiply that by a number greater than 1. So we're always thinking with the x, we think opposite. With the y, we think about it being exactly as it's supposed to be. So with that being said, as I look at question number 1, one of the things I'm going to do is I'm going to go through and I'm going to kind of give myself a little bit of I'm going to jot some notes underneath each one of these problems before I actually start finding the coordinates. So it says suppose 3, 8 is a point on f of x. Give the new coordinates for g of x using the following rules. So looking at A, I see x minus 2. So thinking opposite, I'm thinking it moves to the right 2. And the 6 that's on the outside of f of x means that I'm going to have a vertical stretch by 6, so times 6. So as I kind of think about what that equation is giving me, I'm going to add to my x value, and I'm going to multiply by 6 on my y. B, I have the 3 times x, so that is going to be a horizontal, and this is going to be a shrink, actually. So I can kind of think of this as a horizontal stretch or shrink by multiplying by 1/3, because remember, it's an x, so I'm thinking opposite. And on the outside, I have minus 9, so I'm thinking go down 9. Looking over at C for g of x, I see the negative 1/4 out in front, so that is on the outside, so it's a vertical stretch for my y's, and that is going to be times negative 1/4. The negative actually tells me that I have a reflection over the x-axis as well. And the x has no change. So you'll notice that there is no change to the x. The vertical stretch times 1/4, however, is for the y. Looking at g of x for letter D, I notice that nothing changes on the outside. So y has no change. But for the x, I have that negative x. So really that's kind of like thinking that's a horizontal stretch, if you will, times negative 1. And really what that's doing, we know that that negative is just meaning that I'm flipping over the y-axis. Looking at E, I see in the parentheses x minus 10. That tells me I'm going to the right 10. Remember, it's the opposite. And for the y, I have a vertical stretch times 2. And then I want to go up 3. So I'm going to do 2 things. I'm going to multiply by 2, and I'm going to add 3 to that y coordinate. Let me kind of separate these with some commas so we know that we have the difference between x's and y's. Looking at f, it says g of x equals the opposite of f of x. So x has no change. X, no change. If you look in the parentheses there, the x is still just x. So there is no change there. On the outside, I have a plus 6 and I have a negative. So that is a vertical stretch times negative 1. And then I also have to go up 6 because of the plus 6. For g, it says g of x equals the 1/2 x. So there's a horizontal stretch. And remember, we're thinking opposite. So we're going to multiply by 2 over 1. Okay, that reciprocal. And on the outside, the plus 2 tells me I have a up 2. Looking at h, inside the parentheses, I have x plus 5, so that tells me left 5. Because again, x's are opposite. And for the y coordinate, I have a vertical stretch times 1/8, and then also go down 1. So I'll subtract 1 at the end. And for I have the negative on the inside, so that is a horizontal stretch. It's actually just a reflection, though, times -1. And on the outside, the plus 12 tells me that I'm going to go up 12. So those are kind of the things going on in my head that I'm thinking about, okay, this is what it tells me to do. And now I'm just actually going to do this, and I'm going to use the 0.38. So as I look at this point right here, 0.38, let me change colors. Right here, 0.38. I'm going to do exactly what my rules are telling me. So in part A, it says go to the right 2, or add 2 to the x value. So 3 plus 2 is 5. And then the 8, it says I'm going to vertically stretch it by a factor of 6. So I'm going to multiply that 8 by 6 and get 48. So my new point is 548. For part B, it says for the horizontal stretch, so my x has to get multiplied by 1/3. So it was 3. 3 times 1/3 is 1. And 8, it says it's going down 9, so I'm going to subtract 9 from 8. 8 minus 9 is -1. For C, it says the x has no change, so I'm going to leave it 3. And the y value, it's a vertical stretch, so I have to take my y value and multiply by -1/4. 8 times -1/4 is -2. For D, it says there is a horizontal stretch, so my x gets multiplied by -1, so 3 times -1 is -3. And the y, there is no change, so it stays 8. For E, it says move to the right 10, or add 10. So 3 plus 10 is 13. And now for the y value. I have to first multiply by 2, and then go up or add 3. So my value was 8. 8 times 2 is 16, and 16 plus 3 is 19. For F, the x is no change, so it'll stay 3. And the y value, 8 times -1 is -8. And then it has to go up or add 6. -8 plus 6 is -2. For G, it says that we need to horizontal stretch times 2. So 3 times 2 is 6. And for my y coordinate, it says go up or add 2. 8 plus 2 is 10. For H, it says go to the left 5, which is subtract 5. So 3 minus 5 is -2. And my y values, I have to multiply by 1/8 and then subtract 1 because it's going down. So 8 times 1/8 is 1, and 1 minus 1 is 0. And the last one, I, says the horizontal stretch is -1, so 3 times -1 is -3. And the y value of 8, I have to add 12 to it, and 8 plus 12 is 20. And that is how I go about doing problems like question number 1. Question number 2 says, if the function g of x equals x squared, it's vertically compressed by a factor of 4. Remember, compressed is vertically. That means it is a y value. So as I start kind of thinking, what does this actually mean? This means that I'm going to take my g of x function, and it says that I'm going to vertically compress by a factor of 4. So that means that 1/4, that is a compression. Divide it by 4. And vertical, so I'm going to do it exactly as it says. It says that it's shifted left 3 units, so I'm going to hold off on that for just a second. That 3 units left. I'm going to hold off on that. And it says 7 units down, so down meaning -7. Because remember, the Y's don't lie, if you will. The Y's don't lie. It's going to tell you exactly what to do. Compress it. That means I'm going to divide. And down, meaning I'm going to subtract. Now the x's, I always have to think opposite for my x's. So it says here, shift left 3. So my brain says left 3. I should be thinking that's in the minus direction, but it's always opposite. So I'm going to have x plus 3 would actually move it to the right-hand side. So this is kind of what my brain is now telling me. This is what I have to think. So the new function, if you will, the g of x function is x squared. So my x squared is my x plus 3 squared. The 1/4 still goes out in front. The -7 still goes in the back. So my new function would be 1/4 x plus 3 quantity squared minus 7. Going along with that, let's go right into number 3. I'm going to stay in the same color blue because it's the same kind of concept. We have a vertical stretch. Vertical meaning it's not going to lie. That's my up and down. And we have a reflection over the x-axis. We know that the x-axis reflection deals with y's. So I don't have anything changing my x's. Nothing changes my x's. So my g of x, nothing changes my x's. But I have this stretch of 2. There's my stretch of 2. And the reflection over the x-axis just means that there's a negative sign out there. So we just said g of x is x squared. So my new function is -2 times x squared. That one was a little bit easier. I think 3 was a little easier than 2. Let's take a look at number 4. Number 4 says, list the 4 transformations that have occurred. So we have 4 things that have happened. 1, 2, 3, 4. What are the 4 things? I'm going to start with this negative sign. There's a negative on the outside. That means my y values have changed. So my y values, if I think about it, my y values are up here. So they've switched from top to bottom. They've flipped. So that is a reflection over the x-axis. So the first thing that's been done is a reflection over the x-axis. That takes care of the negative sign. Now the 1/2 is next. That is a compression. It is 1/2 is smaller than 1. So I have a vertical, it's on the outside still, so vertical compression of factor 2. Now some people will say, is this kind of like a stretch of 1/2? And it is kind of the same thing. A vertical compression of factor 2 just means that you're dividing it by 2. It's getting smaller by that factor of 2. I'm going to stick with the last vertical thing, which is the other thing on the outside, the -3. And this is a translation down 3. So everything on the outside, remember, I'm taking it for face value. Take it for what it's worth. It'll tell you exactly what it is that it wants you to do. Up, down, stretch it up or compress it, up and down, reflect it over the x-axis, all that fun stuff. When I deal with the x's, I always think opposite. So when I look at the +4, The plus 4, typically you would think logic would tell us plus 4 would mean right 4, but remember we're always thinking opposite. So this is a translation. And thinking opposite, it's not going right, it's going left. 4 units. So the 4 transformations: a reflection over the x-axis, a vertical compression by a factor of 2, a translation down 3 units, and a translation to the left 4 units. Question number 5 says, consider a parabola with the equation h of x equals 2x squared plus x minus 8 for each. Show all work and state the transformation that is occurring. So let's first determine the formula for the negative of h of x. This is pretty easy. This is the y value, so I'm going to do exactly what it says. I'm going to do the opposite of h of x. Well, what is h of x? Well, it's 2x squared plus x minus 8. That is h of x. So if I want to do the opposite of h of x, I just distribute this negative sign. Negative times 2x squared will give me negative 2x squared. Negative times positive x is negative x. And the negative of negative 8 is plus 8. Now, what is this transformation? This is a reflection over. And let's think about what's happening. The sign is on the outside. That tells me my y's are changing. My changes are happening up and down. My y's are changing, so that reflection goes over top of the x-axis. When I look at B, it says do h of negative x. So this means plug negative x into the equation of h. So I'm going to have 2, and I'll plug in negative x squared, plus plug in negative x minus 8. Well, I know that negative x quantity squared is negative x times negative x, which is positive x squared. So this will become 2 and positive x squared. Plus negative x is the same thing as minus x and minus 8. So you'll notice those are a little bit different from one another. Now the good news is this is still a reflection over. This is still going to be a transformation. This is still a reflection. Those negatives tell you it's a reflection. But this is a reflection over. Let's think about what's happening here. If my x values are the ones that are changing, and I'm moving left to right, I'm reflecting over the y-axis. That'll be something that you'll want to make sure that you pay close attention to when you're flipping over the x-axis versus when you're flipping over the y-axis. Question number 6 says, consider a parabola with the equation h of x equals 8x squared minus 6x plus 5. And let's this time do some compressions and stretching of this. So it says, determine the formula for h of 1/2 x. This means plug 1/2 x into the h equation. So the h equation is 8x squared. Well, x, I'm replacing it with 1/2 x. Minus 6x, 1/2 x, plus 5. You'll notice I've just replaced the old x with that new quantity, 1/2 x. So this will be 8, 1/2 x. Quantity squared is 1/2 x times 1/2 x, which would be 1/4x squared. Minus 6 times 1/2 is 3x plus 5. And let's clean up term number 1. 8 times 1/4 is 2x squared minus 3x plus 5. What transformation is this? Remember, I'm dealing with x, so I'm going to think opposite. Always thinking opposite when it's x. So that 1/2, typically my brain wants to say that is a compression, but because it's opposite, this is a horizontal. Horizontal meaning along the x-axis. Stretch by a factor 2. but that is a horizontal stretch by a factor 2 instead of the shrink as some people might want to think it is. And for part B, it says determine a formula for h of 3x. So I'm going to kind of do the same thing I did in that first part, but instead of replacing the x with 1/2 x, I'm going to replace it with 3x. So 8, 3x squared minus 6, 3x plus 5. 3x quantity squared is 3x times 3x, which is 9x squared. 6 times 3 is 18x plus 5. And clean up term 1, 8 times 9 is 72x squared minus 18x plus 5. So multiplying by 3 on the inside with x, think opposite. So I'm not stretching, I'm actually a horizontal, it's still on the horizontal axis. Compression this time by a factor of 3. By a factor of 3. And that takes care of question number 6. Question number 7, what we did today in class, we talked about even and odd functions. So an even graph, even functions are symmetric about the y-axis. Symmetric about the y-axis. Remember what this means. It means that any f of x and the f of negative x, if I do a x value and the opposite of the x value, they have to be the same y. They have to be the same y. And I will have an even function. An odd function has some symmetry about the origin. So origin. And this means 180-degree rotational. So 180-degree rotational symmetry around the origin will make it an odd graph. Again, f of x and f of negative x, they're not exactly the same. Okay? They're really, really close to one another. They're the same number but opposite signs. I want to make that a negative and say that one of them equals the opposite of the other one. And that will give me an odd graph. So we're going to be able to see this in play in question number 8. So question number 8 says, fill in the table of values for each of the given functions and graph on the grid provided. I'm actually going to use a calculator for this, just to kind of expedite this process a little bit. So the first thing I'm going to do is I'm going to bring up the calculator and I'm going to put in x squared minus 5. X squared minus 5. There we go, x squared minus 5. And the first thing I want to take a look at is I'm going to take a look at the table of values. So the table of values. Now, I have from negative 3 to positive 3. The calculator gives me from negative 5 to positive 5, but that's fine. As I throw this down in there, you can see that this function from negative 5 to 5 has the values negative or positive 20, 11, 4, negative 1, negative 4, negative 5, and then negative 4, negative 1, 4, 11, and 20. Kind of repeats itself. And also I'm going to take a look at the graph of this. So let me see what the graph, oh boy, I'm going to have to do a zoom 6, give it a standard window, and there's a good picture of it as well. That's kind of what the picture would look like. So the question is this function even or odd? And then give a reason in regards to the table and the graph. So as I look at the tables, I look at values like negative 3 and positive 3. The y value for both of them is 4. If I were to look at 1 and negative 1, their y values are both negative 4. So I would say that this is absolutely an even function. And the reason is f of any number and the opposite of that number are the same. And if they're the same, then it is even. The other thing I could look at is looking at the graph. The graph does have a line of symmetry, and it is the y-axis. So the y-axis is the line of symmetry for the graph. So if I wanted to give a reason, I would say that it has y-axis symmetry. Has y-axis symmetry. Doing the same kind of thing, I'm going to take a look at example B. Don't need that. I have x cubed, so let me go back to my y. I have x cubed minus 6x. And I'll start with the table first. That in there. And then let's take a look at the graph as well. That over here. All right. And so I can take a look at this graph, and I need to know if this is even or odd. As I look at my values again, I'm going to kind of choose the same values as I look at 3 and negative 3. You'll notice that the y values are not the same. One is positive 9, the other is negative 9, but they are opposites of one another. If I wanted to look at 1 and negative 1, you would see I have at negative 1 I have positive 5, and at positive 1 I have negative 5. So again, they're not exactly the same, but they are opposites. So since I have f of x, any number, and the opposite of that number, as I look at the y values for those two things, I realize that they are opposites of one another. So this function is odd. If I'm looking at the symmetry of the graph, there is no line symmetry to this graph over here. But what I can do is I can actually rotate it 180 degrees upside down, and the graph looks exactly the same. So this has what we call symmetry about the origin. So this has 180 degree rotational symmetry. About the origin. So hopefully you're good with the even and odd functions. I know we just covered it and it is showing up on the test, but if you have any other questions, please let me know, and happy studying. Good luck.